Hello friends, welcome to Learners Forum. So last video was about mesh analysis. So this video is also about mesh analysis, which is a continuation. So in case when we are supposed to perform mesh analysis with the current source, then what is the procedure will be this particular topic. So that is super mesh analysis will be the topic for this video. So before starting with the analysis, we should know what is called as a super mesh. So the definition is when the current source is shared by two meshes, then it is called as a super mesh. That is, in case if you consider a circuit in this way, here we have got two meshes and in between we have a common current source which is getting shared by the two meshes, which means this is called as a super mesh. So in case whenever we have circuit in this way, then the procedure to be followed for solving this particular circuit will be called as super mesh analysis. So let us solve an example first so that we can understand the concept even more better. So given is an example where we have to calculate the value of current using mesh analysis, and here the circuit is given. So in this, using the same procedure, let us solve for this particular circuit. So the first step is we have to calculate the number of meshes available in the circuit. So in case if you observe the circuit, here we have got first mesh, second mesh, and here we can take it as third mesh, and we can assign the mesh currents as I1, I2 and I3. So in total we have got around 3 meshes and the current assigned are I1, I2 and I3. This is the first step. Second step is for each mesh we have to write the equation. So let us consider the first mesh, mesh 1. So here we have to apply KVL starting from the voltage source here, since it is from negative to positive. So the value is 2 and here it is moving from plus to minus. So there will be a voltage drop. So minus the value of resistance is 2 and the current flowing across this particular resistor is I1. So 2 I1. Next, through this particular resistor, here again we will have a voltage drop, so minus the value of resistance is 1, and here we have got the current as flowing in this direction, that is I1, and we have one more current I3 which is flowing in the opposite direction. So as we have seen in the previous video, we have to consider the dominant current, that is the current across the particular mesh we have considered. So here we are talking about the first mesh, so I1 is our dominant current. So I3 will be the least dominant value. So it will be I1 minus I3. Next, across this particular resistor, again from plus to minus, so voltage drop, so negative, value of resistance is 1. Again we have two currents flowing in opposite direction. So since we are talking about the first mesh, it is I1, which is the dominant current, minus the other current flowing in the opposite direction is I2, which is equal to 0. Let us solve this. So we will get 2 minus 2I1 minus I1 plus I3 minus I1 plus I2, which is equal to 0. Solving this, we will get minus 4I1 plus I2 plus I3 is equal to minus 2. Let this be first equation. Now let us solve for the second mesh. So considering the second mesh starting from this particular resistor, so when it is flowing from plus to minus, it will be voltage drop. So minus value of R is 1 and the current is, now we are talking about the second mesh. So the dominant current available in the second mesh is I2. So I2, again we have one more current flowing in the opposite direction, which is I1. So it will be I1, that is minus I1. Next, across this resistor, again here we have two currents as I2 and I3. The dominant one is I2, so it will be minus 1 into I2 minus I3. Next, across this resistor, here we have got only one current, so minus 1 into the current flowing is I2, which is equal to 0. Solving this, we will get minus I2 plus I1 minus I2 plus I3 minus I2 is equal to 0. So I1 minus 3I2 plus I3 is equal to 0. Let this be the second equation. Now let us solve for the third mesh. So in mesh 3, we have got the current source. So we are writing everything in terms of I into R, since the voltage is represented as V is equal to I into R. So the current flowing is I3 here, and the value of current is given directly, which is 2 amperes, which means in the mesh 3 the value of current I3 is equal to 2 amperes, which is given in the question. So here we cannot identify the value of voltage. That is the reason why we are taking the value of current, which is given directly from the question, and writing it in this way. So we have got the value of I3. Let us substitute this value in our second equation. So this is our third equation. Substituting 3 in 2, we can get it as I1 minus 3I2. I3 value is 2, so plus 2 is equal to 0. So I1 minus 3I2 is equal to minus 2. Similarly, we can substitute the third equation in first equation and get it in terms of I1 and I2, and then we can solve. If we take this as fourth equation, we can solve this both, we can get the values of current. So substituting the value of 3 in first equation, it will be minus 4I1 plus I2 plus 2, which is equal to minus 2. Therefore, minus 4I1 plus I2 is equal to minus 4, which will be our fifth equation. Now let us solve fourth equation and fifth equation. So fourth equation is I1 minus 3I2, which is equal to minus I2. Here we have got minus 3I2, here it is just I2. So we can write it in either way. So first let us keep the fifth equation as such, and we can multiply the fourth equation with 4, so that we can get fourth equation into 4 will be 4I1 minus 12I2, which is equal to minus 8. So this will get cancelled, and here we will get minus 11I2, which is equal to minus 12, from which I2 is equal to 12 by 11 amps. So the question asked is, we have to find the current flowing which is mentioned in the circuit diagram. So this is the current we are supposed to find. So the current flowing here is nothing but our I2 current. So I2 value which we have obtained is 12 by 11 amperes. So this is how we have to solve the question whenever there is a current source which is shared by the circuit elements. So in the last example, we just had the current source in a separate one which was not shared actually. But in this example, let us consider the actual case of a super mesh. Here we have a current source of 2 amperes which is shared by the two meshes. So in the first mesh, we have the current as I1, and in the second mesh, we have it as I2. Both the meshes I1 and I2 are sharing this particular current source of 2 amperes. So whenever we have a condition like this, we have to follow this procedure, which is we have to remove the current source and then we have to form a loop. So applying this particular step, the circuit will be so the centermost current source is removed, but still we have a current of I1 here, and here we have it as I2. The values are going to remain the same. So this is the procedure when we have current source which is shared by the two meshes. Now we have to use the usual procedure, just applying KVL. So starting from this 4 voltage source, let us start. So since it is from minus to plus, we have it as 4. Next, through this particular resistor there is a voltage drop, so minus, value of R is 1, and the current flowing through this particular resistor is I1, so 1 into I1. Next, we don't have any element here. When it comes to here, again from plus to minus, so voltage drop, value of R is 1, and the current flowing through this branch is now I2, so it is I2. And next is from plus to minus. So minus the value of voltage is 2, which is equal to 0. Solving this, we will get it as 4 minus I1 minus I2 minus 2 is equal to 0, which means I1 plus I2 is equal to 2. So this is our first equation. Next, we have to consider this particular current source which is mentioned here. So just have a look at the direction of the current source here. I1 is flowing in this way, which means in the opposite direction to the given value of current source, whereas this I2 is flowing in this condition, that is the direction remains the same. So whenever we have two different current sources acting in this condition, then the total value can be written as the dominant one, because these two have the same direction, so it is I2 minus the other one I1, which is equal to the total value of current which is mentioned here, which is 2. So this is the steps that we follow whenever we have a super mesh condition. First step is we have to remove the particular current source and we have to form a loop like this condition, and we have to apply KVL. With that, we will get the first equation. To obtain the second equation, we have to consider the current source, where we have to look up at the two currents flowing across the same branch, which has to be equated with the given value. And when we are equating, we have to make sure that we are checking for the direction to be matched with the given current source. So I2 is matching with the current source direction which is given here. So I2 will be the dominant one. So I2 minus I1, which is equal to the source value which is given as 2. So this will be our second equation. Now we have to solve these two equations to get the value of current. So we have to find out the value of current flowing across here, which means the current flowing here is I2. So we have to calculate the value of I2. So I1 plus I2, which is equal to 2, which is our first equation, and minus I1 plus I2, which is equal to 2, is our second equation. Solving this, we will get 2I2 is equal to 4. Therefore, I2 is equal to 2 amperes. So this is the value of current that we are supposed to find. So this is how we have to perform super mesh analysis. Let us solve one more example for the super mesh condition. So we have to calculate the power supplied by the voltage source. So this question is from GATE question paper 2010, and we have solved the same question using KVL and KCL laws in our previous videos also. Now let us apply this mesh analysis procedure and solve for the question now. So in this condition, we have a current source here. If we consider the mesh, we have first mesh and the current is I1, second mesh with the current I2, and the third mesh with the current I3. So here the two meshes 1 and 2 are sharing this current source with a value of 1 amperes, which means we have to apply super mesh procedure here. So the procedure for super mesh analysis is we have to remove this particular current source and we have to form the loop here. So doing that, we will get the circuit without this particular current source. Again, we have one more current source here which is shared by the second mesh and third mesh. So we have to remove this particular branch also. So after performing these two steps, we can redraw the circuit. So which will be, we have a resistor here followed by one more resistor, and here we have a voltage source of value 10. So here we have I3 current, here we have I1, here we have I2, and the value of resistor are 1, 1, 1 each. So this is the minimized circuit diagram. Now let us apply KVL here. So starting with the voltage source, since it is from plus to minus, there is an voltage drop, so it will be minus, the value of voltage is 10. Now here across this particular resistor, the value of current flowing is I2. So since it is from plus to minus, we will have 1 into I2. Next, across this resistor, again it is minus I2. Here minus I1 now, since the current I1 is flowing here, and across this resistor again minus I1 which is equal to 0. Solving this we will get minus 2I1 minus 2I2 is equal to 10. Dividing it by 2 and also removing the signature, we will get I1 plus I2 is equal to minus 5, which is our first equation. Now we have to look at the current source. So this particular current source, whenever it is considered, just look upon the direction. So I1 will be in the opposite direction, whereas I2 will have the same direction as the current source, which means I2 will be the dominant one. So I2 minus I1 will be equivalent to the value of current is 1. So this is our second equation. Now for this particular current source, if we have a look, the current flowing is I2, which is opposite, whereas I3 is same as the current source direction. So I3 will be the dominant one. So I3 minus I2 is equal to 2 will be the third equation. Now let us solve the first equation and the second equation. So we will get I1 plus I2 is equal to minus 5 minus I1 plus I2 is equal to 1. Solving this we will get 2I2 is equal to minus 4. Therefore I2 is equal to minus 2 amperes. So we are supposed to calculate the value of power supplied by the voltage source. So that is the value of power across this particular voltage source. So here we have to calculate the value of current, which is I3. So to calculate I3, let us substitute the value of I2 in third equation. So I3 minus I2, minus of minus will be plus. So 2, which is equal to minus 2, which means, sorry, it is plus 2. So I3 is equal to 0. So the power value is product of voltage into current, and the current flowing is I3. Voltage source value is 10 into I3 value is 0. So it will be 0 watts. So if you check with the previous video, there also we have got the same value of power as 0 watts. Just the method of calculation alone matters. So in case if you are very clear about the concept of supermesh analysis, you can use this procedure, or you can directly apply KCL and calculate it in the same way. So this is the procedure to solve circuits in case of supermesh analysis. Let us solve one more example. So determine the mesh currents I1 and I2 for the given circuit. So here we have a current source which is shared by the first mesh having a value of current I1 and second mesh having a value of current I2. So since it is sharing, it means that we have to apply super mesh analysis procedure. So we have to remove this particular current source and we have to take it as a complete loop, which means we can get the circuit as just with the other elements in this way without the change in values of the elements. So here we have got the current value as I1 and here it is I2. So this is the simplified circuit. So here we have to apply KVL starting from the 12 volts. Since it is from minus to plus, it will be 12. Next, across the 9 ohms resistor, it is minus 9 into current flowing is I1. Next, across this resistor, it will be minus 3 into current flowing is I2. Next, here it is minus 6 into I2, which is equal to 0. Solving this, we will get minus 9I1 minus 9I2, which is equal to minus 12. Simplifying this, we will get 3I1 plus 3I2, which is equal to 4, which can be our first equation. Now we have to consider this particular current source and the direction of I1 and I2. I1 is flowing in this way, which is similar to the current source direction. So the dominant one is I1. So I1 minus I2 will be equivalent to 1.5, which is our second equation. Now let us multiply the second equation with 3 so that we can simplify this. First equation is 3I1 plus 3I2, which is equal to 4. Multiplying the second equation with 3, we will get 3I1 minus 3I2 is equal to 4.5. And taking the total value, it will be 6I1, which is equal to 8.5, which means I1 is equal to 8.5 divided by 6, which is equal to 1.416 amperes. So we have calculated the value of I1. Question is all about determining the value of mesh currents I1 and I2. So we have to calculate I2 also. So substitute the value of I1 in this equation. We will get it as 1.416 minus I2 is equal to 1.5. So I2 will be equal to 1.416 minus 1.5, which is equal to minus 0.084 amperes. So these are the values of I1 and I2 which is asked in our question. So this is the procedure to solve mesh analysis, and in case of super mesh analysis also. In case if you have any doubts, you can post it out in the comment section. Thank you so much, friends.